distance between the bases. The shortest distance between the bases. So I want you to refresh your memory of what we did before, naming the bases of the trapezoid, name the legs, and find the missing angle measures. We've done this before. Let's see if you can remember how to do it. Take a minute to do that. Mark these as congruent. That makes it isosceles, which means that angle, well, here, the bases are these two. They're parallel to each other. Well, for this one they are. They're not always. The legs of the trapezoid are HG and E and EF. And if this is 45 and this is congruent, then that's also 45 degrees. It's a four-sided figure. What do the angles add up to? 360. So if I do 360 minus 45 and 45, which is 90, I have 270 left over for these two. 135. So 270 divided by 2 is 135. Okay? All right. Does anybody know the area of a trapezoid? How do you find it? What's the formula?
It's like something plus something equals something.
It's half the height times B1 plus B2. Gentlemen? So it's half the height times B1 plus B2. That's what you're working with here. So we're going to practice with that. Find the area of the trapezoid. So here, first of all, I got to identify my bases. That's these two right here, B1, B2, or vice versa. The height is always perpendicular to the base, so I'm going to make that my height. Why is it not this?
Because H is shorter.
And it's the shortest distance, and it's perpendicular to the base. Very good. And there's no number on here, but if there was a number on here, it is still not your height. Okay? So let's write down the formula and plug in what we know. It doesn't matter what you make B1 and B2. You can flip those. It doesn't really matter. I don't know the area. I know the height is 6, and it's 18 plus 24. So let's see how much of this we can do without a calculator. What's half of 6? Half of 6 is 3. 18 plus 24 is 42. You could probably do that with without a calculator. Do you know how? You do 3 times 40, which is 122, or 120, and 3 times 2, which is 6, and add 120 and 6. But you don't have to do it without a calculator. I'm just saying, think about it sometimes. Am I done? It's naked.
Yeah, it's naked.
What does it need?
Dress.
It needs centimeters squared for the area. Okay? It needs centimeters squared. All right. Now, find the value of H given that the area of the trapezoid is 120. They're giving me the area. I have to find the value of H, or the height. Now, ladies and gentlemen, sometimes they're twisted. So you have to really look at the picture and say, where's the bases? Maybe I would turn it like this. Look here, the height is perpendicular to the bases, isn't it? So these are my bases. Name this B1, B2, or vice versa. It doesn't matter. And then here's my height, which I don't know. So now I'm going to plug in what I do know. Here's my formula. Plug in, Tristan, I'm not going to say it again. You need to move your desk so you pay attention. Plug in the areas, 120. Substitute A with that. 1/2. What's the height? We don't know. We know the bases. I'm going to say B1 is 13, B2 is 7. Substitute in what I know, and then let's see if we can do some math here. We can. I'm going to say, I'm going to keep this one half times h. What's 13 plus 7? So I added those together. Can I take half of 20 at this point? I can, because it's all multiplied. It doesn't matter what order you do it in. So I'm going to do that. I'm going to take half of 20. And I'm going to write it as 10h. Don't be confused by the fact that I didn't put dots here. Doesn't it still mean multiply? Yeah. And now what do I do to finish this problem? Divide by 10. H is equal to 12. Don't leave it naked. 12 what? Feet, not feet squared. It's not area. It's just feet. Okay? Okay, so that's that one.